right, so we're doing section 1.1, which is on graphs. Okay, all right. Graphs and graphing utilities is what it's called. If you do not have a TI-83 or TI-84 calculator or above, I highly recommend getting one. All right, if you can afford it, it is a great tool to have in any math class, TI-83 or TI-84 calculator, or any statistics class too. I know a lot of you have to take elementary statistics as well. So yeah, I highly recommend that calculator. I will show you some things with the calculator today when we're doing some graphing stuff as well. Yeah, and I'll probably use the TI-83 calculator here because I have a little emulator that crashes half the time, but still. Yeah. Okay, so we're going to be talking about graphs, right? And so we're basically just going to have a lot of definitions today, right? And we'll have some examples to sort of illustrate it. So our first subheading here is points and ordered pairs. Now, I am actively working towards writing a little bit neater. So if there is anything that you can't read that I'm writing, please let me know. This thing is pretty tricky, but I'm going to try to write as neat as possible. Okay. I know my handwriting has never been the best. DEFN is my abbreviation for definition. Right. So anytime I'm going to define a word, put DEFN by it basically, and then I'll underline the word that I'm defining. Okay. So definition here. The Cartesian. Okay. It's a funny word. Cartesian coordinate system. Coordinate system. I'm going to underline that. All right, which is also known as the rectangular coordinate system, which is a little bit easier to say. But it's more commonly known as the XY plane, right? The XY plane, right? Is a two-dimensional space. Right, which just means just like a sheet of paper, it's flat, right? Two-dimensional. Okay. With a horizontal axis. Right, usually called the x-axis. Not always. X-axis. Okay. And a vertical axis. Right, usually called the y-axis. All right. Can everybody read that? Yeah. Or at least can they hear what I'm saying and then they're able to interpret what it says? Okay, good. But again, if you ever have any complaints about my writing or anything like that, just raise your hand and ask me about it, and I will be happy to repeat myself and maybe write it a little bit neater. Okay. Okay. So the place where the two axes meet, right? So the place where the two axes, right, the horizontal axis and your vertical axis cross each other or intersect, right? The place where the two axes intersect is called the origin. Origin. All right, good. So now that we have that, right, what does it mean to be a point, right? A point, right? Let's say A, B. Where A and B are real numbers. Maybe that needs a little bit of explanation as well, right? What is a real number? Well, basically any number you can think of is a real number, whether it's a fraction or a rational number, right? Or a square root of a number, right? Or anything like that. The only numbers that are not real numbers are things that have the imaginary unit I in it, right? Which happens when you take in the square root of a negative number, right? And we'll kind of cover that later. But for now, let's just say that real numbers are any number you can think of, right? So here, A is some real number. Maybe it's 7. and B is some real number. Maybe it's negative 500 over 3. Okay. So a point AB where A and B are real numbers, right, can be plotted on the XY plane. Where A is the distance that the point is from the y-axis, from the vertical axis, I'll say. Right? And traditionally, right, if A is positive, the point is to the right. Of the x-axis. Oh, sorry, of the y-axis or vertical axis. And if A is negative, the point, coffee cup's getting in the way here. The point is to the left. Right? So A is your distance away from the y-axis. How far is your point away from the y-axis? It doesn't tell you any your vertical position at all, but it tells you your horizontal position, right? Okay. And B is I'll scroll up a little bit here, distance. The point is from the horizontal axis. Okay. And then traditionally, right, if B is positive, the point is above. See when that happens. Oopsie, there we go. The point is above the horizontal axis. And I'll just say x-axis. And if B is negative, the point is below the horizontal axis. So I'm defining a bunch of things which are probably obvious to you, right? I mean, you've taken high school algebra, right? You've plotted points before, you know how to do it. But why am I going through these very basic definitions? Is because, well, sometimes I have non-traditional students who haven't like done any form of mathematics in a very long time, right? And so they need a little bit of a refresher on how to plot points and things like that, which is totally fine. Okay. So now that I have the formal definition there of like what a point is and how to plot it in a 2D plane like this, right? Let's do an example. Okay. So let's see. Here is some axes, right? So here's your horizontal axis, which remember is traditionally the x-axis, right? Here's your vertical axis, which is traditionally the y-axis, right? Right over here, this point is called the origin, right? Origin, right? And it is 0 units away from the x-axis, and it's 0 units away from the y-axis. I guess I should have said 0 units away from the y-axis and 0 units away from the x-axis. So then its coordinates, right, must be 0, 0, right? Okay. All right, I'm gonna draw a new set of axes here. Here's x, here's y, right? Let's put some scaling on here. Maybe I'll do, this is 1 unit, this is 2 units, this is 1 unit, this is 2 units, 1 and 2, and 1 and 2, right? So this is 1 unit, this is 2 units, right? This is also 1 unit away from your vertical axis, right? But it's to the left of it, so this must be a -1, right? And this is -2, right? This is 1 unit away from your horizontal axis, 2 units away from your horizontal axis. This is also 1 unit away from your horizontal axis, but it's below it, so it's going to be -1, -2, right? Okay, right? And so we can label our axes in this way, right? And then now we can plot points, right? Like let's say the point 2, 1, right? So this point right over here is 2 units away from your vertical axis, right? And it's 1 unit above your horizontal axis, right? So that's why its coordinates are 2 and 1, okay? Which is different than this point, which is 1 unit away from your vertical axis and 2 units above your horizontal axis, right? And so we see that 1, 2 is not the same thing as 2, 1, right? Fair enough. Yeah, it matters the order that you write these numbers in, right? This first number tells you how far away you are from the y-axis, your vertical axis, right? This number tells you how far away you are from your horizontal axis, right? Okay, fair enough. I'm going to stop saying that. I'm going to say this tells you your x position and this tells you your y position, right? Okay, fair enough. It's just easier to say. So there's your x coordinate, there's your y coordinate. Okay. All right. So good. So then 1, 2 is not the same thing as 2, 1, right? And so that's why these are called ordered pairs. Ordered pairs. Because the order matters, right? Fair enough. Since 1, 2 is not the same thing as 2, 1, clearly they're different things, so the order matters. All right, so any questions on that? Okay. And of course, we could plot negative numbers too, right? Here's a -1, -2, right? And then here is the point -1, 1, right? And so on and so forth. Okay. All right. So more definitions here. This is actually going to turn out to be pretty important when you go into college trigonometry, if you do go into college trigonometry. The quadrants, okay? So the axes divide, and I'm just going to call it the XY plane, into quadrants, which just means 4 equal parts, basically, okay? Quadrants. So let's do one more set of axes over here. So the first quadrant is the one where X and Y are both positive, right? So this is quadrant 1 right over here, okay? And then it proceeds in a counterclockwise fashion about the origin, right? So the quadrant 2 will be over here, quadrant 3 will be down here, and quadrant 4 will be over here, right? So we're just kind of rotating counterclockwise here, right? The reason we're rotating counterclockwise is because counterclockwise is canonically the positive direction of rotation, yeah, and which we're going to cover in college trigonometry and everything, okay? So if we formally define what quadrant 1 is, right? Quadrant 1, right? Quadrant 1, right, which I'm abbreviating as Q1, right? It's a set of points, right? So it's got an x coordinate, it's got a y coordinate, right? Such that x is greater than 0 and y is greater than 0, right? That's how you'll see it defined in a textbook. The curly braces just mean it's a collection of objects. That's all the little curly braces mean, right? And then I have to tell you what the format of the objects is, right? It's an ordered pair, right? And then I have to tell you something about the coordinates, right? And so x has to be greater than 0 and y has to be greater than 0, right? Fair enough. So this is just some notational thing, okay? You may see this in some of your homework assignments, okay? Quadrant 2, right? So if you're in quadrant 2, then you're to the left of the y-axis, so you must have a negative x coordinate, right? Okay, so it's still points x, y, but now x is less than 0, and y is still greater than 0, okay? Then we'll go on to quadrant 3. Quadrant 3. Okay. Still points x and y, but now you're to the left of the y-axis there, so your x-coordinate is negative, but you're also below the x-axis, so then y is negative as well, right? Okay. And then quadrant 4. Okay. So now you're still points x and y, but now you have that your x-coordinate is positive again, because you're to the right of the y-axis, and your y-coordinate is still negative. Okay, so there we have it. All right, those are the 4 quadrants. All right, so any questions on that? So then, for example here, right, we have like, let's say the point -1, 2. That has a negative x coordinate, a positive y coordinate. So this is in quadrant 2, right? Fair enough. And a point 2, -1, right? Well, that is a positive x coordinate, a negative y coordinate. So this is in quadrant 4. Okay. Yeah. So we'll refer to the quadrants at times. Like I said, it is super important in trigonometry. Okay. Okay. So that's a bunch of definitions. I'm going to throw some more definitions at you though. So here's our next subheading here, graphs of equations. Okay. All right. So here's a definition for us. An equality, right? Between two quantities or expressions is called an equation. What is an equality? It's where you're saying that something is equal to something else. That's all an equality is, right? So it means it uses the equal sign, right? Yeah. And so you have something on the left-hand side and you have something on the right-hand side, and we're saying they're equal to each other. Therefore, we're going to call this an equation, right? Okay. What is a quantity? Well, it could be a number. It could be a function of x, right? We haven't talked about functions yet, but it could be something times x plus something else times y or whatever, right? It could be any number of variables multiplied together, added together, right? Any kind of algebra done to it or arithmetic, okay? So an equality between these two quantities or expressions, sometimes they're called, right? I'll often call them mathematical expressions or algebraic expressions, right? That's going to be called an equation, right? So the difference between an expression and an equation is expressions don't have equal signs in them, right? If I just say 3x plus 2, right? That doesn't have an equal sign in it, right? So that's an expression. 3x plus 2 is an expression, okay? But if I say 3x plus 2 equals 4, right? Well, that's an equation, right? I was saying that 3x plus 2 is the same thing as 4, right? Fair enough, that's an equation, okay? Okay. So, I'll say this. We will mostly be concerned with equations in one or two variables, right? And what are they going to be the variables names? Well, x and y. Usually X and Y. If we're doing an application problem, sometimes it makes sense to have T for time, right? Yeah, or W for weight, or H for height, right? Fair enough. But usually X and Y. All right, so just as an example of what some equations are then. Right, we have let's say 2y equals 3x. That's an equation, right? Or how about negative 12x plus 3y equals 5x squared? That's another equation. And then y equals 4 minus x squared. That's an equation as well. Okay. So all it takes to be an equation is you have an expression is equal to some other expression. Okay. Okay. Having that now, here's another definition for us. A solution of an equation in two variables. Right. I mean, what does it mean to be a solution of an equation in one variable, right? Like 2x minus 4 equals 8, right? Well, it just means it's an x value that when you plug it in, you get a true statement, right? All right, so if we let x be, I don't know, 6, right? Then we get 6 times 2 is 12 minus 4 is 8. So then we would say that x equals 6 as a solution, right? Fair enough. So I'm going to start it off with what is a solution of an equation in two variables then? Fair enough. Okay, so a solution of an equation in two variables. Let's say that the variables are x and y. Okay, is an ordered pair. A, B. Okay, so that when x equals A and y equals B are substituted into the equation, substituted into the equation, right? A true statement ensues. Okay, fair enough. So you get something that's true when you plug it in, right? In this case, we say that the ordered pair AB satisfies the equation. Okay, satisfies the equation. So as a quick example of that, right? Let's look at y equals 4 minus x squared. So I claim that 1, 3 is a solution to y equals 4 minus x squared. Okay, so let's prove it, right? So we're going to let x equal to 1, and we're going to let y be equal to 3 and see what happens, right? So we have y equals 4 minus x squared. We're going to substitute that y is 3, right? We're going to substitute that x is 1. I'm going to put parentheses around things that I'm substituting in. It's not necessary in this particular problem. However, it's probably going to be very good practice for you to do that because of things that we're going to be doing a little bit later. So as I'm substituting things in, I'm probably going to put parentheses around it. Okay. So since x is equal to 1, I have parentheses around the 1, and that's being squared. So then now, simplify this. Left-hand side is just 3, right? 1 squared is just 1, so 4 minus 1 is also 3. That is a true statement, right? So then when we plugged in x equals 1 and y equals 3, we got a true statement, and that proves that 1, 3 is a solution to this. Okay. So any questions on that? Okay. Okay. I'll make one more quick definition here. The collection of all solutions to an equation. Right? So there could be more than one, right? So there could be infinitely many for all we know. Right? So the collection of all solutions to an equation is called the solution set. Solution set of the equation. Okay. All right. So we're going to talk a little bit about solution sets in a bit. But I want to talk about graphs right now. Okay. So before we can talk about a graph, let's make the following note. Note this. We can, it says note. We can generate as many solutions to y equals 4 minus x squared as we want. Right? And how do we do that? Well, by just letting x be equal to something, right? So we're going to let x vary and then solving for y. Okay. So I'm going to organize my work here in a little chart. Okay. So I'm going to put some x values over here in this column. All right, it's called a table of values. Okay. I'm going to put my y values, which remember that y is equal to 4 minus x squared here, over here. And then I'm going to put solutions to y equals 4 minus x squared in this column. Okay. So let's see some good x values to plug in. How about -3, -2, -1, 0, 1, 2, and 3, right? Just something symmetric about 0. You don't have to have it be symmetric about 0. You don't have to have it be whole numbers for that, for matter. I could have let it be a square root of 5 or something like that if I wanted to. I just chose some nice easy numbers though. Okay. Now let's see what this y value is going to be. So here, remember that I'm plugging in that x is -3. I'm going to put parentheses around it, right? That's what I mean about how it's important to put parentheses, right? Yeah. So then now we see that -3 is being squared. So that's going to be a +9 when I square it. But I'm still subtracting that, right? So 4 minus 9 is -5. Okay. Any questions on that, by the way? I know for some of you this is trivial, but like for others, like, arithmetic is maybe not the easiest thing. Any questions at all? Okay, let's try this then. So I'm plugging into x is -2, right? So we get 4 minus, well, -2 squared is +4, so we get 4 minus 4, which is 0. Okay. Now we'll try -1. So we have 4 minus -1 squared, so that's going to be 4 minus 1 is 3, right? Now we'll try plugging in 0, so we get 4 minus 0 squared, which is 4, right? We'll just keep on going here. Y equals 4 minus 1 squared, which is 3. Y equals 4 minus 2 squared, which is going to be 0. And then y equals, yeah, I don't know why I smushed all this over here. Let's spread it out a little bit. There we go. Y equals 4 minus 3 squared, which is -5 again. Okay. All right, so then what are the solutions to y equals 4 minus x squared? Well, from this x coordinate, I get that y is -5. So then -3, -5 is a solution, right? -2, 0 is a solution. -1, 3 is a solution. 0, 4 is a solution. 1, 3, 2, 0, and 3, -5, right? These are all solutions to y equals 4 minus x squared. And then, of course, there are more solutions as well, right? There are infinitely many solutions, right? Fair enough. All right. But now that we have that, let's plot these points. Okay. Let's just plot these points. So let's see. I'll do it off to the side over here. I think I got enough space. Okay, I'm going to need a lot of y space over here, particularly since the y values go from -5 up to +4, right? Okay. My x space, I only have that going from -3 to +3. So I'm going to make my x-axis a little bit shorter here. X and y. Okay, so my y-axis needs to go up to 4. So I'll say 1, 2, 3, 4. And it needs to go down to -5. So -1, -2, -3, -4, -5, right? And if I don't label my tick marks on my axes, I just know that they're counting by ones, right? Fair enough. So then if you're 5 ticks away and below, then that's -5. Okay. All right, and then your x-axis is going to go 1, 2, and 3, and -1, -2, and -3. Okay, so let's plot these points. When x is -3, we're over here at -5. When x is -2, we're over here at 0. When x is -1, we're over here at 3. When x is 0, we're over here at 4. Right? When x is 1, we're over here. Am I going too fast? No. We've all graphed things before. Yeah. All right. I just want to make sure I'm not going too fast here. So when x equals 2, we're at 0. And when x equals 3, we're at -5. All right. So those are the solutions that we found, right? But like we said, there are infinitely many solutions because we could plug in any x value we want. For example, between -3 and -2, we could plug in any x value we want between -3 and -2, and we could find a y value that works, right? So we could find any solution there. So there are infinitely many solutions between this point and this point right here. So let's imagine those solutions by connecting these two dots. Okay, right? So we know that there are infinitely many solutions between here and here. Okay, and there are infinitely many solutions between x equals -2 and x equals -1 as well, and between x equals -1 and 0. All right, right. So if we connect these dots, we get a nice little visualization of what the solution set looks like, and we know it just keeps on going, right? And it keeps on going, right? Infinitely many solutions, right? Yeah, and I know that's not the best picture, right? All right. But yeah, we get a nice little visualization of the solution set. It's all those points, right? So now I'm going to define what the graph is. Okay. Definition. The graph of an equation. And two variables. And two variables. Okay, so I'll underline graph over here. Is the set of solutions to the equation. All right. So it's the solution set is all it is. Yeah, that's what the graph is. It's just a solution set. Right. And so how do we find it, right? By plotting points and connecting the points. With a smooth curve. We get a visualization. Visual, not two L's. Visualization of the graph. Okay. Nice little visual representation, right? Okay, again, all stuff that we already knew, right? Nothing new about that. All right. Let's do some practice then. So let's see. We get out of here at 10:45. Okay, just making sure. So let's do some practice here, right? Let's do the absolute value function. Okay, so let's graph y equals the absolute value of x. Okay. Have we all heard of the absolute value of x, by the way? Has anybody not heard of the absolute value of x? Yeah. Okay, so absolute values are basically just the distance that something is away from zero. That's all it is. So like if we look at a number line, right? I was about to write on a piece of paper here. So we look at a number line, right? So here's the real number line. Let's say zeros right here, right? -1, -2, +1, +2, right? So we've all seen number lines before, right? Yeah, it's basically just a single axis, right? Well, this point over here is 2 units away, right? 2 units to the right of 0. And so we say that the absolute value of 2 is just equal to 2 because it's 2 units away. It's the distance that it's away from 0. Okay. Now, this point right over here, right? -2, right? This is 2 units left of 0, right? 2 units to the left of 0. So then we'll say that the absolute value of -2 is also 2, right? Because we only want the distance that it's away. Distances are never negative. Okay. And so that's what the absolute value is. It's just the distance that a point is away from 0. That's all it is. Okay. Fair enough. Okay. So, this little curly brace means I'm going to be defining a piecewise function. Okay. Now, what is a piecewise function? Well, it just means that your y value is going to follow a different rule depending on what interval your x value is in. Okay. So for example, if I'm taking the absolute value of a positive number, right? If x is positive, right? Well, then the distance it's away from 0 is just itself. It's just x. Yeah, fair enough. However, if I plug in a negative x value, right, like -2, right? Well, the distance that it's away from 0, right? I need to somehow get rid of the negative sign, right? Yeah. Any questions on that? So how do I make a negative number positive? Well, I multiply it by -1. So if x is negative, right? If I have some negative x value, then the absolute value of x will just be -1 times x. Okay. Yeah, and a lot of people get confused at that. Yeah, a lot of people get confused at that. This negative x over here, because they say, oh, well, isn't this now a negative number? No, right? This is -1 times x, right? So this is a negative number times a negative number, which is definitely positive. Okay, fair enough. So here, remember, we're under the assumption that x is already negative. So if we multiply it by -1, that makes it positive. Okay, I'll prove it to you. Right? Here we have x is less than 0. Let's subtract x on both sides of the inequality. Right? So then I get x minus x should be less than 0 minus x. X minus x is, of course, just 0. 0 minus x is negative x. So I have that negative x is bigger than 0. Right? It's a positive number. Right? So there we have it. When x is negative, negative x will be the distance that that point is away from 0. Okay. Okay. So this is how the absolute value function is defined. It is literally a piecewise function here. Okay. The absolute value of x will just be x if x is positive. It'll be negative x if x is negative. What happens if x is equal to 0? Well, we can just lump it in this rule, right? 0 is 0 units away anyway. So For x greater than or equal to 0, we'll say the absolute value of x is just x. Okay. All right. So any questions on that? All right, well, now we can just kind of plot points, right? So here's x, here's y, right? Equals absolute value of x, right? So let's say we go from -3 to +3 again, okay? So -3, -2, -1. So remember that y equals absolute value of -3, all right? That's the same thing as multiplying -3 by -1 to get +3, right? Right? Y equals the absolute value of -2, right? Well, I have to take -2. I got to multiply it by -1, right? -1 times -2 is +2, right? Right. So for any of these x values that are negative, right, I need to multiply by -1 to make it positive. Okay. Fair enough. All right. Now 0, 1, 2, and 3, that's easy, right? For anything that's greater than or equal to 0, I'll just use the same x value basically. So when x is 0, y, which is equal to the absolute value of 0, will also be 0. Right? Y, which is equal to the absolute value of 1, will also be 1. Y, which is equal to the absolute value of 2, will also be 2, and so on and so forth. Right? Fair enough. I say that way too much. Fair enough. All right, let's plot it. Okay. All of my y values are positive. That's kind of the thing about absolute value of x. It's always positive y values, right? Okay. So my x values, 1, 2, 3, -1, -2, -3. My y values 1, 2, 3. I didn't label my axes. Here's the x-axis. Here's the y-axis, right? Okay, let's plot my points here. 0, 0 goes right here. 1, 1, 2, 2, and 3, 3. Ooh, don't like that. I need to make it so that it doesn't try to correct me. Oh, okay. I guess we'll just get rid of everything then. That's cool. All right, there we go. Okay, so those are my 0 through 3 then. Okay, and then now for -1, -2, and -3, my y values are 1, 2, and 3 respectively. So x equals -1, y equals 1, x equals -2, y equals 2, x equals -3, y equals 3. Okay, and now we connect it all with a smooth curve, but we see that for these non-negative x values, right, everything's in a same line with slope 1. So this is really just a line. Your smooth curve is really just a line here, right? And for your negative x values going down to 0, right, we see that it's also still just a line. They're all on the same line. So your smooth curve is a line there as well. Okay, so that's what the graph of y equals absolute value of x looks like. Okay, any questions on that? Okay, so good. Now let's talk about intercepts. Okay, which are a very important feature of graphs. Graphs. Yeah. Intercepts. Okay, so an x-intercept, right? An x-intercept of a graph, right? Which is also called a root, right? Right. Sometimes it's called a solution even, but I'll omit that part. Okay, so an x-intercept of a graph, or a root, if you want to call it that, is the x-coordinate. Oh, and I said the x-coordinate. I guess I should say a. Okay. Wow. I don't know all these shortcuts, I guess. Is an x-coordinate of a point where the graph intersects. Where the graph intersects the x-axis. That's why it's called an x-intercept. It's intercepting the x-axis, right? Okay. The y-coordinate of any x-intercept, right? So this is, remember, this is where it's intercepting the x-axis, where it's actually crossing the x-axis. So it must be that your y value is 0, right? So the y-coordinate of any x-intercept is just 0. Yeah. Fair enough. Goodness. Now, a y-intercept of a graph, right, is a y-coordinate of a point where the graph intersects the y-axis. Right? Okay. And then, of course, right, if you're crossing the y-axis, your x-coordinate must be 0, right? So the x-coordinate of any y-intercept is 0. Okay. It turned out to be pretty important in actually finding x-intercepts and y-intercepts. It sort of gives you a strategy for how you might go about trying to find an x-intercept or a y-intercept. Okay. So as an example here, as a quick example, right? Find all the x-intercepts and y-intercepts of the following, right? So find all intercepts, means x and y-intercepts, of y equals 4 minus x squared. Okay. So let's start with x-intercepts. Right? So remember that if you are an x-intercept, your y-coordinate is 0. So the way that I'm going to start off by finding it is I'm going to let y be equal to 0. Right? Fair enough. So when I plug in that y is 0, I get that 0 is equal to 4 minus x squared. Okay. And there are a couple different ways you might do this, but I think the easiest way that you could do this one is let's just add x squared to both sides of the equation. Now, I know I have some non-traditional students here, right? So anytime you have an equation, all right, as long as you do the same operation to both sides of the equation, then it gives you an equivalent equation, basically, right? Something easier to work with, maybe, right? Yeah, but you have to do the exact same operation to the left-hand side as you do to the right-hand side, right? If you're multiplying by 3 on the left-hand side, you got to multiply by 3 on the right-hand side, right? If you're dividing by 7 on the left-hand side, you got to do dividing by 7 on the right-hand side, right? If you're squaring the left-hand side, you got to square the right-hand side. If you're taking the integral of the left-hand side, you got to take the integral of the right-hand side, whatever that is, right? Yeah. Fair enough. So here, I'm going to add x squared to both sides of the equation. So my left-hand side was 0. I'm going to add x squared to it. My right-hand side was 4 minus x squared. I'm going to add x squared to it, right? So I'm adding x squared to both sides of the equation there. Okay. All right. Now the parentheses totally don't matter. I'm subtracting x squared. I'm adding x squared. So those are totally going to cancel off, right? On the left-hand side, 0 plus anything is just itself. So we get x squared, right, equals 4. Okay. Any questions on that? All right. Now I have x squared equals 4, but I want to know what x is, right? So what do I have to do to both sides of the equation? Yeah, somebody said a square root, right? You got to take the square root on both sides of the equation, right? So the square root of x squared is equal to the square root of 4. Okay. All right. Now, here's a tricky question. What is the square root of x squared? All right, you say x. Sometimes it's x. Sometimes it's x, right? Think about the square root of x squared is it always returns a positive number. Right? So for example, if I take the square root of 4, that's always going to give me positive 2. It'll never give me negative 2. Right? It's always positive 2. Right? If I take the square root of negative 2 squared, right? Well, that's the same thing as the square root of positive 4. So that's still going to give me positive 2. It'll never give me a negative number. Okay? Never. Right? Now, x is a real variable, which means sometimes x is a positive number, sometimes x is a negative number. So the square root of x squared, well, yeah, it can be equal to x if x is positive. But if x were negative, then the square root of x squared would totally not be equal to x. All right? Because you can never get a negative number out of a square root. Okay? So then the square root of x squared is not always equal to x. Sometimes it's equal to the absolute value of x. Right? Fair enough. Oh, I should say this. It's always equal to the absolute value of x. Yeah. Square root of x squared is always equal to the absolute value of x. Fair enough. And that goes for whenever you're taking the square root of any quantity. You always get the absolute value of that quantity. Okay, fair enough. So on the right-hand side, square root of 4 is 2. Yeah, it's definitely 2. So I have a new equation. The absolute value of x is equal to 2, which means that x is 2 units away from 0, right? So that means that x is either positive 2 or negative 2, right? Fair enough. And so that's why when we take square roots, like when we're solving quadratic equations, sometimes we're taking square roots, right? We always get this plus or minus that comes out of it, right? It's basically a shortcut to get from here to here, right? Saying that x squared equals 4 is the same thing as saying that x is equal to plus or minus 2, right? Fair enough. That's where the plus or minus comes from, though, is the fact that when we take the square root of x squared, we get the absolute value of x. Okay. And I just wanted to point that out to you guys. Okay. All right, I guess I got to click on this one with the mouse. All right, let's get rid of my arrow there and get rid of that. Okay, so now that we have that, right, that's my x-intercepts, right? I'll get rid of this too. So x equals plus or minus 2, right? So that's the same thing as saying that x equals 2 is one intercept and x equals negative 2 is another intercept. Okay, yeah. Just in case you've never seen a plus or minus symbol before as well. Okay. Now, sometimes in MyLab math, it'll want your x-intercept as a point. They want you to write it in point form, in ordered pair form. But remember that your y-coordinate is just 0 if you're an x-intercept. So then this is the same thing as having 2, 0 and having a negative 2, 0 be your x-intercepts if they want it in point form, right? So I'll write over here in red, right? This is as a point. Just because sometimes they'll ask for it that way in MyLab math. Okay. Right, they want it as an ordered pair like that. Okay. All right, so any questions on that? All right, now let's do the y-intercept. Right. And I'm going to put the S on there. Turns out there's only one y-intercept. There are reasons for that, which we'll discuss at some point. Y-intercept. So remember, if you're a y-intercept, you're crossing the y-axis, which means your x value has to be 0, right? Because you're 0 units away from the y-axis. Okay. So we're going to find our y-intercepts by letting x be equal to 0, right? So we have y is equal to 4 minus 0 squared, right? So then that just means that y is equal to 4, right? And we're done, right? There's your y-intercept, y equals 4, right? If we write it as a point, right, then that means that, well, your x-coordinate is 0, your y-coordinate is 4, right? So there it is as a point. Okay. All right. Any questions on that? Any questions on that?